This is going to be the recording for Thermal Energy 2.4. And so we are going to continue to talk about how heat and energy can be transferred from one object to another one. And another term we're going to introduce is equilibrium and kind of figure out what that means and kind of use the simulation to figure that out. One thing here, you can see this GIF. This is called Newton's cradle, and that's going to be one thing that you are going to read about today, and that has to do with energy transferring. You can see it starts from one side and goes all the way through, knocking the other ball on the opposite side out. So that's a pretty cool little device. And when you click on today's lesson, it will bring you here to the assignment for today. And so first thing you're going to see is that there is a warm-up that has a few pictures. I have sample A and sample B. And this yellow arrow means that my energy is being transferred from sample A to sample B. And then this is a temperature graph for sample A. So it can show the temperature over time of that sample. You can see it kind of drops and then evens out. And so the first thing that I'm going to need you to tell me is, what does this graph up here tell you about the temperature of sample A over time? And then thinking about what happens here, we see sample A is moving its energy over to sample B. And if you remember from our heat transfer, hot to cold. So that's about the only hint I'm going to give you, though, because I don't want to give it away. And so I want you to tell me what you think the temperature would look like for sample B. What would that graph look like? You're thinking hot to cold. The next thing is we're going to open the simulation. And remember, this is a hyperlink, so you can click on this and open that up. You can also see my cat's face. Double the cat. So when this loads, you are going to put two samples in here of the same size. Finally, well, maybe I spoke too soon. There we go. So we're going to add two samples. So I'm going to do two medium. And then what I'm going to do is I'm going to make one as hot as I can get it. And then I'm going to make one as cold as I can get it. So my sample A's temperature is 100, and then my sample B is 0. So go back in here, and I would say that my starting temperature of sample A is going to be 100. and then my sample B would be 0. And now I'm going to put them together and see what happens. I'm going to turn on my 2 toggles to see what's happening. And I can see that the energy is transferring. I can see by this yellow arrow, the energy is transferring from sample A to sample B. So it's traveling from the hotter sample to the colder sample. And eventually, you can see they're starting to get closer in temperature. And eventually, they will stop. Almost there. And there we go. They have eventually stopped transferring, and so I can see that both temperatures are at 50. So then I would have my final temperature be 50 and 50. And so looking at that data, there are a few questions down here about the transfer of energy and what the temperature is like. And so you'll have to read through these questions here and highlight which answer is correct. And remember, the highlight tool is up here, and you will just drag and highlight which one you agree with. The next thing is going to be reflecting on stability. So we're kind of slowly moving into stability and equilibrium, which are two things. So stability is when things stay the same, and then obviously changes when they don't. So looking at these 4 systems, I want you to tell me which ones, if I put them together, because obviously they are all separate now, which ones would have a change occur if they got put together. Just like we had 2 separate temperatures and then we put our samples together and there was a change. So which one of these would have a change if they came in contact? So you're going to highlight which ones. And it's really important to pay close attention to details, because like these, we can see that these two are 79.5 and 79.5 in their temperature, so we know that they are the same. So if they're the same and they get put together, we're probably not going to see a change. But the opposite of that is like these two look like they're going to be the same, but they're actually not. They have a 61.4 degree temperature and then a 65.9. So even though they look like they're the same color, they're actually different. So you want to pay attention to your details and make sure you're looking at your temperatures and all that. All right, continuing. There is a little reading down here, and it's about molecule collisions and Newton's cradle, which is this toy I talked about. And it kind of explains how Newton's cradle works, and that idea of pulling one of the balls back and then it bounces and that energy transfers all the way through to the opposite side. And the cool part about that is that none of the ones in the center move. So the one on the outside is pulled and then the energy transfers all the way through and it knocks the opposite one. So that's pretty cool. And I highlighted a few important pieces of information when I was reading with my classes, whichever class you were in. And then there is a question down here. So when a moving object collides with an object that isn't moving, what happens to that kinetic energy? And so you will find the answer to this in the reading above. And then equilibrium. Equilibrium, I'll just write it in here. Equilibrium is a balanced state in which a system is stable. Here's lagging. 2 or more samples are the same temperature. There you go. Except that is not spelled correctly. Yeah, so when 2 or more samples are the same temperature. And then the last part is down here, you're going to see that I have a few examples. So there's these 2 samples and then these, oops, where'd they go? Here they are. And then there's 2 more sets down here. I don't know where this one went. Hopefully it pops up on yours. And the idea is that you are going to tell me if each sample is at equilibrium or not. So the equilibrium means it's stable, it's the same. So either it's at equilibrium or it's not at equilibrium. And you can tell by looking. This one right here has 2 temperatures. I don't know why it's not loading on mine, but hopefully it loads on yours. And if not, leave it blank. But these, you're going to have to find the average. So you're going to have to add all these numbers together and then divide it by how many numbers there are. So there are 9 numbers. So I would add all these together and divide it by 9. I would do that for each sample and then tell me if it's at equilibrium or not. So that should be it. That should be good.